Welcome back for another example of matrix multiplication. We're given matrix A and B and asked to find matrix B times matrix A. If you watched the previous example, we found matrix A times matrix B. The order of matrix multiplication does matter. So notice in this case, matrix B is first, which is a 3 by 2 matrix, and matrix A is second, which is a 2 by 3 matrix. Now that we have this set up correctly, the next step is to make sure this product is defined. We can only perform matrix multiplication if the number of columns in the first matrix is equal to the number of rows in the second matrix. So again, our first matrix is a 3 by 2 matrix, and the second matrix is a 2 by 3 matrix. So to see if this is defined, these two values here must be the same, which they are. So this product is defined. If these weren't equal, the product would be undefined. When we have it set up like this, the outer numbers give us the dimensions of our product, meaning the dimensions of the product will be the number of rows in the first matrix by the number of columns in the second matrix. So this product will be a 3 by 3 matrix. Just to compare, if we go back and take a look at matrix A times matrix B, as we see here, notice how the product was a 2 by 2 matrix, which emphasizes the importance of matrix multiplication, as well as the fact that matrix multiplication is not commutative. Now to find the 9 elements in this 3 by 3 matrix, we'll be using rows from the first matrix and columns from the second matrix. To know which row and column to use, we have to know the location of each element. So for example, if we want to find the element in row 1, column 1, which would be A sub 1, comma 1, this is telling us that we'll use row 1 from the first matrix and column 1 from the second matrix. So to find this element, we want to multiply row 1 by column 1, which means we'll find the sum of the product of the first elements and the second elements. So A sub 1, comma 1 is equal to negative 2 times positive 4 plus 3 times 2. This would be negative 8 plus 6, which is equal to negative 2. So A sub 1, comma 1, or this element here, is negative 2. Let's go ahead and work our way across the first row. So the next element would be A sub 1, comma 2, which means we'll use row 1 from the first matrix, but now we'll use row 2 from the second matrix. So now we would have negative 2 times 1 plus 3 times negative 5. This would be negative 2 plus negative 15, or negative 17. Next element would be row 1, column 3, or A sub 1, comma 3. So now we'll use row 1 from the first matrix, but we'll use row 3 from the second matrix. So we'll have negative 2 times 3 plus 3 times 7. This would be negative 6 plus 21, which would be positive 15. Now we'll go to row 2, so we'll find A sub 2, comma 1. So now we'll use row 2 from the first matrix and column 1 from the second matrix. So we'll have negative 4 times 4 plus negative 2 times 2. So we would have negative 16 plus negative 4, that's negative 20. Next we have row 2, column 2. So we'll use row 2 from the first matrix and column 2 from the second matrix. So we have negative 4 times 1 plus negative 2 times negative 5, which would be negative 4 plus 10, or positive 6. And next we have row 2, column 3. So we'll use row 2 from the first matrix and now column 3 from the second matrix. So we'll have negative 4 times 3 plus negative 2 times 7. So we'll have negative 12 plus negative 14, which is negative 26. Okay, we have 3 more elements to find. Next we'll go to row 3, so a sub 3 comma 1. We'll be using row 3 from the first matrix and column 1 from the second matrix. So row 3, column 1. So we'll have 5 times 4 plus 1 times 2. That would be 20 plus 2, or 22. Next we have row 3, column 2. So row 3 from the first matrix and column 2 from the second. 5 times 1 plus 1 times negative 5. Well, that would be 5 plus negative 5, or 0. And finally, for the last element, which is in row 3, column 3, we'll use row 3 from the first matrix and column 3 from the second matrix. So we have 5 times 3 plus 1 times 7. So we have 15 plus 7, which is equal to 22. So matrix B times matrix A is equal to this 3 by 3 matrix. And again, to compare B times A to A times B, notice that A times B was a 2 by 2, and B times A is a 3 by 3. I hope you found this helpful. I'll finish by leaving some formal notes on matrix multiplication on the screen.